All right, astronomy students, this video is on the tides. And you've already watched the video on the tides. You can read the book all about the tides. They explain things probably way better than me, but I'm glad you're watching this anyway, just because, what do you do? All right, so the moon all by itself makes two tidal bulges. This is the craziest thing, okay? So here is the Earth. Okay, the Earth is blue, big blue marble kind of thing. And let's pretend the moon is out here. Now the moon is 30 Earths away, right? So 1, 2, 3, 4. It would be way off the screen, so I'm going to fake it, put it right here. Okay. Now the moon pulls on the Earth. It pulls on this side harder than that side. So first, this water over here is close, so the water bulges out like that. Now it's not really that much. That would be a lot of water bulge. If the Earth is 4,000 miles, that'd be like a 500-mile high tide or something. But it really, that distance there, really in the middle of the ocean is only about a meter, okay, about a yard, like 3 feet. However, shores and stuff can, depending on where you are, it can be much bigger than that because the way a bay is or something, it can funnel the water and it can slosh back and forth, which is what happens in the Bay of Fundy, as well as it funnels the water and the bottom goes up and stuff, and you can have tides that are like 50 feet high, even though on the average it's only about 3 feet or something in the middle of the ocean. So that's kind of weird. Now here's the weird thing. At the same time, there is a tide over on the other side. I tried to make it the same size. Okay, it's not bigger. Now why is there a tide over here? And it has nothing to do with the sun. Okay, we're ignoring the sun right now. We don't need the sun. The moon is twice as good at making tides as the sun. And that's because even though the sun pulls harder on the Earth, right? We go around the sun, not the moon. The sun pulls harder on us, but the sun pulls about the same as on this side as on the other side because it's so far away that it's not a big difference the way gravity drops off. For the moon, since the moon's a lot closer, though not this close, since the moon's a lot closer, the difference between how hard it pulls here and how hard it pulls there is actually pretty significant. Even though it's not as hard as the sun pulls really hard on this side, or really hard on this side, just a little bit, tiny bit less hard on this side, while the moon pulls hard on this side, but a little less hard. It's a bigger difference in forces. So I'm going to represent those forces with green arrows here. So here, the moon pulls really hard on this side, okay, and not so hard on the other side, so shorter arrows. And therefore, and especially hard on this water, so the water gets pulled towards the moon because the water's loose. Actually, they say the solid Earth, all 8,000 miles thick of the solid Earth, actually gets stretched about an inch. So it does actually, the moon actually does stretch the Earth a little tiny bit, which keeps the Earth a little bit warmer than it would have been. Not much, because it's only an inch over 8,000 miles. But other planets, or like especially the moons of Jupiter, they're really close to Jupiter, a lot closer, relatively speaking, than the moon is to our moon is to the Earth. And they actually get stretched a lot by Jupiter, which actually keeps them really warm. And that's why there's like liquid oceans underneath the icy surfaces of some of these moons where people think there might be life and stuff. It's because of that tidal heating, the fact that Jupiter is like stretching the moons, like our moon stretches the Earth. Then we stretch the moon too, and they think that might cause moonquakes, some stuff happening in the moon. Okay, the point is, here's the idea. On the average, in the middle of the Earth, the arrow's somewhere in between them. Okay, so like medium arrows. Here, short arrows, long arrows, medium arrows. So here is the big thing that's really weird. Obviously, there's a tidal bulge here because the moon pulls the water. Water's loose. It goes towards the moon. We have a high tide here. Okay. On the other side, it's like the Earth itself. See, here's the moon. Here's the arrows for the Earth. It's like the entire Earth is getting pulled with the medium arrows, with these arrows. But this water on the backside is only getting pulled with the little tiny arrows, little green arrows. So the Earth is getting pulled with medium arrows. The water in the backside is getting pulled with small arrows, which means it's not getting pulled as hard as the Earth. So the Earth is getting pulled away from the water. Okay? So the Earth, here's the idea. The Earth is getting pulled away from the water, which makes a tidal bulge on the far side of the Earth. That makes a bulge over here. The water bulges out here, the water bulges out here. As the Earth turns, like let's pretend the moon stays still. It doesn't. It moves 50 minutes a day. We talked about that, but let's pretend to stay still right now. As the Earth turns, here's the Earth now, high tide. turn around. Okay, 6 hours later, that place is on the other side, so it's low tide. 6 hours later, which is 12 hours, it's here, high tide again. 6 hours later, it's here, low tide. And 6 hours later, it's there, it's high tide again. So there's 2 high tides and 2 low tides every day. Now, we know the moon actually moved. By the time we get around back here, the moon has moved 50 minutes. So actually, there are 2 high tides plus 2 low tides every 24 hours and 50 minutes. Because that extra 50 minutes, because the moon actually turned. Which means, let's pretend there's let's say it's a 2 o'clock, 2 p.m., there's a high tide. Now, it would have been 12 hours later there's a high tide, but now it's 12 hours, 25 minutes later there's a high tide. So that means at 2:25 a.m., not 2 because the 50 minutes, we're halfway there, so it's half of 50 minutes, which is 25 minutes. That is the next high tide. And 12 hours, 25 minutes past that, so 2:50 p.m., back to the next day, 2 o'clock in the afternoon, but 50 minutes later, because the moon's turned 50 minutes, we got to line back over the moon, there's another high tide. So every 12 hours and 25 minutes, there's a high tide, and same for low tides. Every 12 hours, 25 minutes, there's a low tide, which means after a high tide, 6 hours and 12 and a half minutes later after the high tide, about 6 hours, right? There's a low tide. So high tide, about 6 hours, 12 minutes, whatever later. Low tide, 6 hours, 12 minutes later. High tide again, which is 12 hours, 25 minutes. Then low tide, then high tide. Happens about, not quite twice a day, because it's twice every 24 hours, 50 minutes. But, kind of close enough. Okay, so that's the way the tides work. Now, the sun actually does help make tides. The sun is about half as good as the moon. The moon wins. The moon is better because it's closer. But even if we had no moon, there would be tides, but they wouldn't be as big. They'd be, I think, a little less than half as big. So let's put our sun up here. Let's say the sun was over here. Of course, not to scale at all. Not even close to being to scale, but whatever. You get the idea. It's big. It pulls harder, but because it pulls about the same on both sides, the difference in the arrows for the sun is less. The difference between the green arrows here for the moon is pretty big. For the sun, the difference is less, so it doesn't make as big tides. So if they were lined up like this, which you can see as a full moon, right? We're looking at here's the dark side of the moon, this is the bright side of the moon. If it is a full moon, then the sun also makes a tidal bulge the same way. It pulls this side towards it, and it pulls the earth away from the water in the back, this whole thing, it pulls the earth away. So they add up. We get an extra high tide when the moon at a full moon. And it works the same way at new moon. When the moon is over here, they both make tides together. They both make, here's the moon's tide is bigger, here's the sun's tide. They both make big tides. These extra big tides are called are called spring tides. Neap is the other one. Are called spring tides. I'm not sure why. It's nothing to do with the spring. It happens twice a month, right? Happens the new moon and full moon. Moon cycles 29.5 days, practically a month. That's why we call it a month. It's a month, right? After they took away one of the O's for some reason. They should put that called a month. It's kind of hard to say. So, twice a month we get a spring tide. We get extra high tides. You go to the ocean, the water's going to come up extra high. It's going to wash away your sandcastle, go out. Okay. Now, twice a month we get an extra low tide when the moon is here or here. Then the moon wins. The moon pulls water this way, but the sun's trying to pull water this way. The moon wins, but it doesn't win by a lot, and the tides are not as high because they're fighting for the water. So those are the quarter moons, right? If you remember the picture we looked at today, those are the quarter moons. So spring tides happen at full plus new moon, and neap tides, the extra low tides, neap tides. And I don't know why neap either. Neap just means small or something. Neap tides happen at first and third quarter moons when you see a half a moon. So if you go to the ocean and you see it's a half moon up there, it's a quarter moon, you say, oh, tides aren't going to be very high. If you want high tides, you're out of luck. And also, by the way, high tide means the water comes up really far and it goes out really far. Both, okay? We have a really low tide and a really high tide. You have extremes. At the neap tides, it doesn't come up as far, but it doesn't go out as far either. So if you want to go on the rocks and look for sea anemones and starfish and all this kind of stuff, you want to go during a full or new moon when you have the more extremes and the water goes out a lot further. Okay, so that's the idea. We now know about neap tides, spring tides, how it affects the moon, because the moon and the sun both make tides. The moon's twice as good at making tides, and the tides it's a 24-hour, 50-minute cycle, and in that cycle there's always two high and two lows as the Earth spins through high, low, high, low, high, low, high, low. You get the idea. Okay, like I said, some places are extra high tides, and because the water gets funneled into bays, like the Bay of Fundy. So I'm going to show a video up here of how the Bay of Fundy makes extra high tides. It's really awesome. It's way more than a meter. Let me turn this thing on. So this is the Bay of Fundy in Nova Scotia, Canada. It's got the highest tides in the world, both because there's a sloshing of the tides. It takes like 6 hours for the water to it's like a bathtub where the water sloshes back and forth. It takes like 6 hours for the water to slosh in, which is just perfect, and 6 hours to slosh out. So it's timed really well with that 12 hours, 25 minutes of going in and out. So let me turn these lights off so you can see this. Okay, let's watch the Bay of Fundy tides. Okay, so here it is at low tide. So again, this takes 6 hours, 6 hours, 12 and a half minutes. So here comes the water. It takes 6 hours for the water to come in, floats up the boats. And I don't know if this was during a spring tide or neap tide. It'd be most impressive if it was during a spring tide, but whatever. So look at that. The boats now are all floating. They go higher and higher. You got to have like docks that can float and everything. So this is now about probably around 6 hours later. It's high tide. And now the tide starts going out again. And it drops all the way back down. This happens twice a day. It's insane. That's so much water. People have tried to get energy from this. They actually have these big turbines in this bay, in the Bay of Fundy, as the water comes in and out twice a day. That's a huge amount of water. It's a huge bay. You can see, right out here in the ocean out there. So now again, 6 hours is going by, and now it's low tide again. And then it happens again, and again, and again, and again, and again, and again, and again. All because of the moon. Pretty awesome. The moon is a pretty cool thing. Look at that. Look how far out the water is. Okay. That's awesome. Okay, a couple more things about the tides and we'll be done. So, first, there are extra high spring tides when the Earth happens to be close to the moon, and the Earth is close to the moon about once every 27.3 days. So when the moon is at perigee, which happens again about once a month, right? The moon goes around the Earth about once a month. So when the moon happens to be close, right, then makes bigger tides. It's closer, makes bigger tides. And if the sun happens to be close, where's my orange pen? Lost my orange pen. If the sun happens to be close, so if the sun is at perihelion, we also have the sun makes bigger tides. So if you get a full or new moon, right, a full or new moon, when the sun is at perihelion, and we know that happens about January 4th every year, and this happens about once a month. And it's not even exactly once a month, so who knows when it is. You look it up when that happens. So when it's perigee, the once a month lines up with a full moon or new moon, lines up with January 4th, you get extra high tides, and it actually makes a huge difference. If you live by the ocean, they'll be on the news. Watch out, tie big ropes onto your boats because they're going to go up extra high today. The water's going to come in extra far, so take all the precautions, and it's a big deal when you live on the ocean. These are called Proxaegean tides. Proxaegean tides. Proxa means close. Close to the geo is Earth, so that means that the moon is close to the Earth and the sun is close to the Earth, right? Proxa Earth. When two things are close to the Earth, the tidal effect gets bigger, and especially when it's a new moon or full moon, because then it's also a spring tide. So when three things happen, three things have to coincide. You have to have perigee. Okay, that's one. You have to have perihelion, so near January 4th. That's two. And that one's always January 4th. This one, you know, once a month, who knows. And you have to have a full or new moon. Full or new moon. Or we could say, we want to be more specific, we should really say it has to be a spring tide, which happens at full or full or new moon. If we have perigee, perihelion, and a spring tide, we get proxygean tides. They're especially high. Okay, so here's the deal. So they happened January 4th. Well, it turns out the year the Titanic sailed, there was the biggest proxygean tide like there's been in a long time. This happened just perfectly. It was like January 4th, and the moon was really close, and everything happened right, and it happened in January. So the water went really, really high in the ocean. The tides went really high that night, and it floated away all these icebergs that were normally on land. They got floated away by all these high tides. So there were way more icebergs in the water than normal. And the icebergs are pretty far north. You know, they're up in Greenland and the Arctic and stuff. So it took them a while to float on the ocean down to where the shipping lanes were. So that year, and what year is that, 1910 or something? I should know that. Anyway, whatever. That year, there was a really big proxygean tide, one of the best ones ever. All these things lined up. All these icebergs got lifted up into the water and floated off way, 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 way more than normal and got into the shipping lanes. So when the Titanic sailed, they got a captain who was really experienced, and he knew when there's icebergs out there because he's been sailing forever. And he knew there's never icebergs out there this time of the year. You know, they don't float that far south, they melt and all this kind of stuff. There's never that many. So he wasn't as careful as he should have been. Or because he didn't think there was any reason to. There's never icebergs there. But he didn't think about, which no one did, there was this big proxygean tide. So that year, there were way more icebergs than normal. And because he was experienced and, you know, didn't care, because, oh, there's never icebergs there, they weren't being as careful as they were, should have been watching out for them. And so the ship hit icebergs and it sank, and we got this movie out of it. And it was sad for, you know, people dying and stuff. So that's why you can say the moon actually sank the Titanic, because it created a proxygean tide because it was extra close, sun was close. The sun helped too, really, but the moon helps more, right? And it made it so that, yeah, you get the idea. So they got way more icebergs out there. So actually, the fact that they had an experienced captain really hurt them. If they had had an inexperienced person who didn't know there weren't supposed to be icebergs out there, they might have been looking for icebergs and they might have seen them. So crazy. Okay, a few other random facts. Because of this tidal friction, so as the Earth turns, here's the Earth turns in the water, right? It turns into the tide. The water rushes up the beach. You've ever been to the beach, right? The water comes in, rushes up the beach. That slows the Earth down. It actually does. It slows the Earth down. Not by much. It slows by about 20 microseconds a year. Okay, you'll never notice it. 20 microseconds is a tiny amount of time. But it adds up. They think the moon's been around about 4.5 billion years from very soon after the Earth formed. They think the Earth formed about 4.6 billion years ago, so the moon's been around a long time. So they think, if you do the math then, 20 microseconds a year, that means that when the moon first formed, the Earth was only turning about 5 hours. It only took about 5 hours for a day back then. That's how much the moon has slowed us down. So if you go 20 microseconds a year, okay, 20 microseconds per year, and you go back all the way back, this is a symbol for micro, this Greek letter mu, 20 microseconds, 20 millionths of a second. If you take that back, then when they think the moon formed, that means the Earth was spinning 5 hours a day. We had really fast days. Imagine if the sun came up every 5 hours, right? Oh my gosh, you go to bed, wake up, go to bed. I'm glad there's a moon here. It kind of slowed things down, made it a little more natural, right? We have a nice length of a day now. 12 hours, about right. Now it'd be nice if night was longer so you could sleep more. I'm sure a lot of you would like that, but what do you do? So, well, wait a while. It's going to get there. We're slowing down still, 20 microseconds a day. And that energy, it turns out, it's not obvious why, but it turns out that energy is making the moon move away by about 2 inches a year. So the moon is moving away about 2 inches a year. Again, you're never going to notice that, but over billions of years it adds up, which means they think the moon was once 10 times closer. Imagine that. The moon was 10 times closer. It would look 10 times bigger in the sky which makes it 100 times brighter. Of course, there would be more eclipses and stuff too, because it'd be easier for the Earth to block it out if it was a lot closer. But isn't that crazy? So the moon, when it's first got here, this is what they think, of course, no one knows for sure, but there's a lot of evidence for these theories. The moon used to be 10 times closer, and the Earth was spinning at 5 hours, days for 5 hours, and since then, the moon has moved further away, and the Earth has slowed down to 24 hours a day instead of 5 hours a day. All right, that was a mouthful. A lot of awesome stuff there about the moon. And we'll talk about the other stuff on a different video. Awesome. Hope you learned a lot about the moon. Moon's a cool thing. It's nice that we have a moon.